Okay, so lesson 1, 4 angles, naming and measuring angles, and the angle addition postulate, which is spelled wrong. Okay, definition of an angle. Take a minute to copy this slide. So pause the video. All right, an angle is formed when two rays meet at a common endpoint called the vertex. So what's a ray? We know a ray has an endpoint and heads in an opposite direction. So we'll call V the vertex. We have A and B. Okay, so we have ray VA and ray VB, and they form this angle in here. Interior of an angle versus the exterior. So the interior of an angle contains all the points between the two sides of the angle. So that would be the interior. Okay, think interior, inside. And then the exterior of the angle would be the region that has all the points outside of the angle. So this would be the exterior. And those terms are important. Okay, so as I'm writing notes, you add it to your definitions. Okay, when we name angles, there's several different ways you can name an angle. Okay, the notation that you'll see me write, that would represent an angle. Okay, this angle here, we can name it X, Y, Z. Okay, so look at the order, X to Y to Z. I can name this angle as ZYX. If I look at where Z is, head in the direction of Y and extend through X. Or I can name it just by its vertex, which is angle Y. Okay, so this angle, I can name it using 3 points, A, B, and C, or angle CBA. I can name it by its vertex, so I can name it angle B. And if I look now in the interior of the angle, it's also numbered, so I could name this also as angle 1. So look on the interior, and I can use that as a 4th name. Okay, so copy this down. Notice here that I have a ray on the interior of angle JKL. So if I were to name all the angles that we can see, angle JKL and angle LKJ, okay, they would be the outermost. I have this angle here. So if I look to this angle here, I could name that as angle JKM or angle MKJ. Now also I look in the interior there and I can name that, no M. I can name that as angle number 2. The name that I absolutely can't use is angle K. So I can't name it by the vertex because I don't know if K is in the larger angle, JKL, or if I'm talking about the smaller angle, JKM. So you're only allowed to use one letter if we just have one angle shown in the figure. All right, classifying angles. So take a minute, copy down the chart. So angles are classified by their measure. So an angle that has a 0 measure, that's the name, a 0 angle, and a 0 angle is a ray just by itself. Okay, so if an angle is defined as 2 rays that meet at an endpoint, then just one single ray would be a 0 angle. If the measure of my angle is between 0 and 90 degrees, this is known as an acute angle. and an acute angle. This measure in here would have to be bigger than 0, but less than 90. A measure of 90 degrees, we've talked about this a lot. We know that that's a right angle. And if a right angle is formed, then those rays will be perpendicular. So we put our marking in there. An angle whose measure is between 0 and 180 degrees is known as an obtuse angle. And the diagram. So this measure in here would be greater than 180 degrees, or excuse me, greater than 90 degrees, but less than 180. Then our last classification is 180 degrees. This is known as a straight angle. And straight angles form a line. So again, if I were to sketch in my right angle, an acute angle is smaller than 90 degrees, but an obtuse angle is bigger than 90, but not a straight angle, which is a measure of 180 degrees. So make sure you have the chart filled out completely. Okay, congruent angles. Recall congruent segments. So I could say that segment AB was congruent to segment CD if the length of AB was equal to the length of CD. Okay, so I can say that two angles are congruent so if I have angle KLM and angle NOP, then angle KLM is congruent to angle NOP if and only if, and I'm going to introduce a new little notation here, the measure of their angles is equal. Okay, so on segments, remember the notation for congruent. If we have segment AB is congruent to segment CD, and we put the tick marks on there. Now with angles, you'll use these little arcs to show that those two angles have the same measure. You might see the arcs with tick marks inside them. Okay, so the notation that matches tells us that those angles are in fact congruent. Okay, take a minute, pause the slide, copy down the definition. Adjacent angles are two angles with a common side, a common vertex, but nothing on the inside is the same. They don't share anything on the inside. So, if I look at this, if I draw this angle in red, if I trace over this, okay, that's one angle. And if I trace the other angle in blue, notice that this is the common side, okay? Here's the common vertex, and on the interior of each individual angle, nothing is shared. Okay, so adjacent angles have to share a common side and they can't overlap at all. All right, so if I had this angle in here, so I couldn't say that the angle that I'm tracing in red is adjacent to the angle I'm tracing in blue here for several reasons. They don't share a common side. This ray is in the interior of the angle that I sketched in blue. So common side, common vertex, nothing else. They don't share anything else. Okay, your angle addition postulate. Take a minute, copy the figure down for me. Okay, so the angle addition postulate. Point B has to be in the interior of angle AXD. Then I can say that the measure of angle AXB plus the measure of angle BXD will equal, so let's check this out. If I have angle AXB, that's this angle here, and then I have angle BXD, this angle in here. All right, I'll put two different tick marks to show that they're not necessarily going to be the same. Then what angle did I form? I formed this larger angle here. So that will equal the measure of angle AXD. Okay, this should look vaguely familiar to our segment addition postulate that said if B was between A and C, then the length of AB plus the length of BC will give us the length of the entire segment. So now we're talking about angle addition postulate as well. Okay, let's do a couple examples of these. Take a minute and pause the slide. Copy down the example for me. Okay, so I'm told the measure of angle ROT. And I have information about these two interior angles. So according to our angle addition postulate, the measure of angle SOR plus the measure of angle SOT gives us the measure of the entire angle, ROT. Okay, so R to O to T, S is in the interior, so that's what breaks up the larger angle. All right, the measure of angle SOR is given as 4x minus 20, plus the measure of angle SOT, that's given as the expression 3x plus 14. And the measure of angle ROT is 155 degrees. So there's our equation. We've talked about this extensively with segment addition. You need an equation to relate the given information to the picture. So combining like terms, 4x plus 3x is 7x. Negative 20 plus 14 would give me negative 6. So I have 7x. When I add 6 equals 161. Okay. This goes in 2 times. 2 left over, bring down the 1. So x is equal to 23. Always go back and answer the question that's being asked. So now to find the measure of angle ROS, I'm going to take my value of 23 and I'm going to plug it in to the expression for ROS. For the measure of angle SOT, I'm going to take my value for x and plug it into that expression. So for homework, complete those two and find the measure of angle ROS and the measure of angle SOT.